All right, geometry. We are continuing on from where we were last time, which is parallelograms. We talked about all the properties. Opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and diagonals bisect each other. Okay, so today we're talking about proving that something is a parallelogram. Okay, so this is still 6.2, but it's going to be day 2 of that. Okay, so with parallelograms, we know opposite sides are congruent and opposite sides are parallel. Okay, so you can prove that something is a parallelogram if you know both sides are congruent, both sides are parallel, or one of each. Okay, so in this method number 1, it says prove both pairs of opposite sides are congruent. Okay, so in this picture here, if AB is congruent to DC and AD is congruent to BC, then ABCD is a parallelogram. Okay, so for that, if we want to figure out if the side lengths are the same, we need to use the distance formula. Okay, and remember the distance formula is when we go, okay, the distance equals the difference of the x's plus the difference of the y's, and you square both of them. So difference of the x's squared plus the difference of the y squared, add those together and then take the square root. Okay, now the other method is both pairs of sides are parallel. So if AB is parallel to DC, or A and AD is parallel to BC, then ABCD is a parallelogram again. But for this, for us to know they're parallel, now we need to use the slope formula. Okay, slope formula, which, again, a reminder of that, m equals y minus y over x minus x. Okay, y1 minus y2 or vice versa, y2 minus y1 over x2 minus x1. Okay, so those are the two formulas we're going to be using. And then method number 3 is proving one of each. So if AB is congruent to DC, and we also know that AB is parallel to DC, then ABCD is a parallelogram. Okay? So in that case, you would use one of each. All right, so we're just going to do one of each on here, and then you can practice the other one on your own. So for this one, using the distance formula, I'm going to prove that ABCD, I'm going to set this up the same way, actually. So here's my picture, A, B, C, D. So AB, I need to see if AB and DC are congruent. So I'm going to go with AB first. So AB is equal to, okay, so x minus x. So that'd be -7 minus 1 squared plus 4 minus 2. So 4 minus 2 squared. And so that's going to be 8 squared, which is, so 8 squared, -8 squared plus 2 squared. And so that's going to be 64 plus 4, which is the square root of 68. Okay. So in the same way, I'm going to go see if DC is the same. So DC, find the same thing. I've got x and x, y and y. So x minus x is 9 minus 1 squared plus negative 8 minus negative 6, so negative 8 plus 6. And that's going to be 8 squared, which is 64 again. Negative 2 squared, which is 4 again. So square root of 68. So far so good. Okay, so I'm going to do the same thing for AD and BC. So AD, I'm going to go A and D, so negative 7 minus 1 squared plus 4 minus negative, so 4 plus 10, plus 6, which is 10. So that's going to be 8 squared, which is 64. And that's going to be 10 squared, which is 100. So 164. So the other is BC. So let's see what BC gives us. BC is going to be 1 minus 9, or so 1 minus 9 squared, plus 2 minus negative 8, so 2 plus 8. And so in this case, I get negative 8 squared, which is 64. 2 plus 8 is 10 squared, which is 100. And we do indeed get 164. So this is a parallelogram. So yes, ABCD is a parallelogram. Okay. And so you do the same thing on number 2, distance formula. Okay. So let's go to set 2. Use the slope formula to see if the parallelogram is indeed a parallelogram. So I need all 4 of these to be parallel. Okay. So I'm going to set up my parallelogram so I know what's what. I've got W, X, Y, Z. Okay. So I need WX to be parallel to ZY. So WX, slope formula for WX is going to be Y minus Y over X minus X. So negative 6 minus negative 4 over 1 minus negative 7. So both of those become plus, and I get negative 2 over 8. So that's negative 1/4. All right. WX is opposite of ZY, so let's find the slope of ZY. ZY is going to be X minus, or Y minus Y on top, so negative 13 minus negative 12 over, so I started with 13, so I got to start with 5, so 5 minus 1. And so negative 13 plus 12 is negative 1 over 4. So those check out. So now we got to try the other two, WZ and XY. So WZ is going to be Y minus Y over X minus X, so negative 12 minus negative 4 over 1 minus negative 7. So that's going to be negative 8 over 8, which is negative 1. Okay, and then the other one is XY. So XY's slope is going to be negative 13 minus negative 6 over, what is that? Negative 13 is 5 minus 1. 5 minus 1. And so I get, it's going to be negative 7 over 4. Oh, that is not correct. So that is not a parallelogram. Okay? And so that's kind of how you prove one way or the other. All right? Kind of checking my math real quick. Yeah, looks right. WZ. Yep, so that would be not a parallelogram. So last one, you want to use one for one, one for the other. So I'm going to go, so J, K, L, M. We're going to find the distance for JK and the slope for JK. So for JK's distance, it's going to be x minus x, so -9 minus -5, so plus 5, and -2 minus 1 squared. So -4 squared is 16, plus -3 squared is 9. And so what we end up with is square root of 25, which is 5. And so let's find the distance of LM. So that's opposite. So 1 minus -3 is plus 3 squared. And then -4 plus -4 minus 7 minus -7, which is plus 7 there. And so we get 4 squared is 16 plus 3 squared is 9, which is indeed square root of 25. So 5. So distance is good. Now let's check for slope. So JK's slope is going to be y minus y over x minus x, so -2 minus 1 over -9 minus -5, so plus 5. And so JK ends up being -3 over, looks like -4. So positive 3 over 4. All right, let's check the slope for LM. Got y minus y, so -7 minus -4 over -3 minus 1. So I end up with -3 over -4, which is indeed 3 over 4. So the slopes check out, and that is a winner. Okay, so you can try those blank ones on your own. We're going to have some homework over that as well to practice using distance and slope to figure out, is this really a parallelogram? All right, peace.